All right, this is one I did in class where I had a problem seeing where there was a horizontal, um, where the slope was horizontal on this. We're going to see that it was fairly a simple concept, and I was seeing the answer, like I said, but I wanted to get the step. What happened is one of those things when you see the algebra, but you try to make a shortcut for it. So what we're going to ask ourselves is, what is dy dx, and when is the slope 0, and when is the slope vertical? So we want to look for a horizontal tangent and a vertical tangent. So what we're going to do is we're going to do the implicit derivation. So we're going to do 3x squared plus 3y squared dy dx. We're going to have a product rule here. So minus 130y minus 130 x, right? Derivative of the first times the second plus the derivative of the second times the first. So we get a dy dx here equal to 0. And we're going to collect our dy dx's together. So I have 3y squared minus 130x dy dx's. And I'm going to put to the other side everything else. So we're going to have minus 130y minus 3x squared. We'll solve for dy dx. I want to bring this negative sign out, so I'm going to get a negative. If I bring the negative out, did I lose a sign here? Oh wait, that's not negative, that's positive. Let me get this correct here. When I bring this to the other side, it's positive 130y minus 3x squared. My bad. And so dy dx is 130y minus 3x squared over 3y squared minus 130x. And so here we have our derivative. What we want to know is when this equals to 0. And the only time this is going to equal 0 is when 130y minus 3x squared equals 0. Now this is an entire solution. Right, if I solve this for y, I'll have y equals 3 over 130x squared. And so that's a parabola. And I want to find this parabola. What I want to do is I want to find when this parabola exists in this curve. So what I'm going to do is I'm going to substitute these y values in to the curve. It's going to and here's where I think I was struggling at the board. I was trying to do the math in my head to see where the numbers were going, and that kind of happens when you're pressed for time sometimes. But what we're going to do instead is we're just going to leave y like this. We're not going to try to work out any of the numbers, and we're going to find this is going to help us a lot. And when I sat down with a piece of paper to do this and didn't try to get a number in the end, but I just moved my numbers about as variables, this solved rather quickly. And I will sometimes we want to see what a value is, and that can sometimes impede us. So I'm going to put in y equals 3 divided by 130x squared. So I get x cubed, and then I'm going to get 3 over 130x squared cubed plus y cubed minus 130x times 3 over 130 x squared, all equals to 0. Now my job here is not to try to figure numbers out. My job here is really to get a relationship in terms of x to constants. So I'm going to cube both terms here. It's going to have 3 over 130 cubed. And x squared cubed is x to the 6th. Whoops, I added this extra y cubed here, I'm sorry. This part here is y cubed, so I'll scratch that out. Minus 130 x times x squared is, let me clean up this previous line here. As I was looking at my notes, I added x cubed in again. I apologize. Talking faster than I want to. So I put in y into y cubed, I get this. Now I need my minus 130x times what I have for y, which is 3 over 130 x squared equals to 0. Good, that's a better place. And now we'll simplify. I'll have x cubed plus 3 over 130 cubed times x to the 6th. These 130s cancel, and I get minus 3x cubed equals 0. So I'm going to bring all my x cubes over to the left-hand side, and I'm going to make this mess over here. So negative 3x cubes and an x cubed is negative 2x cubes, so I have 2x cubes here. Now notice both sides have an x cubed, so I will divide by x cubed. And now I'm in a really good place, because to find x, I'll take the cube root of both sides. And the cube root of the left-hand side is 3 over 130x equals the cube root of 2. And so, cube root. So 130 cube roots of 2 over 3 is x. And if I want to find y, I plug that into here. And so y will be 3 over 130 times 130 over 3 squared times cube root 2 squared. So y will be 130 over 3 times, well, if I square this, that's going to pull out a 2. Right? This is if I have a cube root of 2 and I square it. So I have the cube root of 2 times the cube root of 2. There's a couple different ways we can look at that number that comes out of it, but we can look at it as, if I do a power rule here, 2 to the 1/3 squared is 2 to the 2/3, or the cube root of 4. And so the point at which this has a 0 slope is 130 thirds cube root of 2, 130 thirds cube root of 4. And a similar argument goes for when we want to find the vertical line. What we do is we solve this for 0. And that will give us where we're actually asking for x equals in terms of y. And then we come back in and substitute x up for here. So like I said, I think the solution was simple, but the steps itself had us looking at some odd numbers. And when I was looking for the steps forward, I was mentally substituting back into here. And as Richard had said in class, oh, why not use tables? And this is kind of a tabular relationship. I'm not going to examine you on this, but this is definitely a nice use of our algebra. It's also a nice thing is when you see a problem, one of the things you can do is just take a step back and use your piece of paper. When I was trying to explain what I was doing to you, I wasn't taking that step back. And again, as soon as I sat down on the paper and I got to here, where I needed this top part to be equal to 0, I knew that it also had to be on the curve. And remember, I tried to graph, hey, there's these parabolas this is making. And I was trying to find an intersection with a line to the parabola. What I really should have found was this parabola sitting on this curve. And so sometimes it's good to take a pause and think about what your problem says, and then work your way through the problem. I haven't checked the videos for Pearson for this, but I think the video for Pearson on this is a little meh, so I will send them an email about that. But this is a doable problem. Well, most of the problems we have are.